All right. So we are going to work with the same type of picture all class period. It's going to look like this, where we have a right triangle with the altitude drawn from that right angle. Okay? And altitude. When I say altitude, you're like, yes, I know what you're talking about, or no, I don't know what you're talking about. Okay. Like the height. An altitude is like the height. And like it's drawn from the vertex to the other side at a right angle. So it's like the height. Okay? So when we have the altitude or the height drawn from the right angle, we have this picture. Okay? So what I've done, like, okay, here angle B has one rainbow and angle A has two rainbows. So what we're going to do, we're going to cut along that dotted line. Okay? And when I cut along this dotted line, I get two triangles down here. Both of which are right triangles because of this guy right here, right? Now, here is A right here, and here is B right here. What can you tell me about those two triangles down there?
Well, they're not similar.
How do you know? So like, this guy has two of the same angles as this guy, right? Yes? This guy has two of the same angles as this guy, right? So do we know anything about this angle?
Well, yeah, but it's not the same.
It's this guy, right?
I get it.
I don't think there's some
That one is the same as that one.
Okay, let's just pretend this is 30 degrees and this is 60 degrees. I'm giving random numbers. If this is 60, what's left over here? If this is 30, what's left over here? Okay.
It could be. But like,
No, it is.
how do we know that? Oh, I see.
So we can say that triangle ABC, this triangle right here, is similar to triangle ACD, this triangle right here, which is also similar to triangle CBD, this triangle right here. Huh?
Oh, I get it.
So I went A, B, C. I went blue, green, red. Blue, green, red. Blue, green, red. Okay. All right. So in that little space to the right, by the right, I mean left. Okay. I'm going to have you draw this picture. Yeah. What?
How do you understand that angle equals, how do you know that angle C equals angle A?
Because, okay, so coming back to this picture here, like, are you okay with me, like, cutting these into here? Okay, if it's a right triangle, right? All three of these are right triangles. If this is 90, then these two angles have to add up to be 90, right? Okay, so if this guy is the same as this guy, then its third angle has to be the same. And same thing
because the right angle that was cut.
So these are all similar by,
Right angle.
Angle.
how much is angle? Just angle.
Bang!
Okay.
I basically said that.
Can you please write me okay. Same thing happening here, right? A right triangle with its altitude drawn. Micah?
I don't see the thing for, like, wait, are you
Oh.
talking about MHT being the right triangle? Because there's, okay, thank you. Because
You're welcome.
It's
I-
so amazing in geometry.
You are right, Micah. You are using my words against me. I forgot to draw that. Okay, now that the picture is right, could you please write me the 3 similar triangles?
I was just looking at the ABC.
Yeah. Triangle blank is similar to triangle blank is similar to triangle blank. That's what I want. Are you okay, Colm?
Yes, okay.
I don't need help. I got it down.
Austin asked for help. See, he just said he got it down from D. Need help earlier.
Okay, we will look. I'm not helping Austin today. He's made fun of me too many times.
How did I make fun of you? For a root?
Do the points in the same order.
Wait, say root beer.
Yeah, I did MAHCAH. And then I just did random.
All right. Conway, are you willing to share your triangles?
I'm not all the way done.
I'm sure.
Austin was trying to ask me for help.
Are you wanting to share yours? Okay, you go for it.
Alright, then you got MAH, right? And then you got HAT, right? And then you got MTH for the final triangle, right? Or whatever. Right? Letters and numbers.
I think it should be MHT. Right?
Mahat. Well,
So like this A needs to be in the same spot as that one H because they're all the right angles, okay? This T is the same as this guy. So these T's need to be in the same spot as this H because they're all the green angles is what I'm labeling them. And then purple angle, okay? So these M's need to be in the same spot as this H, okay? All right, so now, all right, so could we write a proportion to help us solve for PS? Okay, so let's see. This, let's call PS X. Can we do that? Can you put an X there?
I can put an X there, don't worry.
Okay, so what I'm going to do is I am going to draw these 2 triangles. That was terrible. P, Q, S. S, R, Q, 9, 12. Okay, so I just like cut them apart, right? And if this is angle P and this is angle R, then I'm just going to mark my 2 cut apart triangles to help me out. Okay? Do we have some corresponding pieces here in our similar triangles? Okay? So help me out. What does this PS correspond with?
QS.
These two right here?
That's all.
Okay, so like x over 12 I can write. Okay.
How can
I wrote this over this, right? Those two correspond.
Oh, correspond. Okay.
Okay, I'm writing a proportion. And then, what other two correspond?
Wait, what's correspond?
They're in the same spot in the triangle.
9 and 12. 12 and 9.
QS and SR, right? Okay, do I need to write 12 over 9 or 9 over 12?
12 over 9.
12 over 9. Well,
Why can you?
what?
Oh, I think I was there when you said did that in class. I wasn't there.
So if two triangles are similar, then that means their sides are proportional, right? Like their fractions are all the same. Like that's how you've been testing side, side, side. You look at the fraction, you look at the fraction, you look at the fraction.
I don't know what you're doing.
So here, my two ratios are the same,
Okay.
right? Okay, so can we solve? Yeah, we can take, all right, 9 times x equals 12 times 12. So how long is PS?
144 divided by 9.
Are you serious?
So.
I told you.
16.
Okay, now, do you find it interesting that that 12 was used 2 times in our proportion?
No, I found
Oh, nobody found that cool? I found it
I
cool.
did.
Yeah?
Yeah, I did. Yeah.
Okay,
I can't really see.
so this is, you can't see?
Because like there's will and then there's also like.
Okay, is that better? Okay, or if you need to move your chair like Logan keeps doing, you can do that too. Okay? So here's the deal. When we have this happening, this right here is something we call geometric mean. So can you write this? Geometric mean. The geometric mean means we have a proportion where the geometric mean would, like, when you cross multiply, they get multiplied together. And then we have the other two numbers thrown in. So in this, so we say x is the geometric mean of A and B. Okay? We have a proportion where the same number gets used twice diagonally, where when we cross multiply, they multiply together. Okay? So we know that we have all of this cool relationships happening. But we can be like, okay, we know what's happening. It's the geometric mean. We can kind of take a shortcut. We like shortcuts, right? Okay. So we're going to write a shortcut at the top of the next page. Are you ready? Yep.
Is that the next page?
Yeah, like next to example 3. When we have the altitude is the geometric mean between the two pieces of the big triangle's hypotenuse. Okay, Alex, I need you to put your computer away. I need you to have your student companion out and participate with us, okay? So your computer needs to be put away. You can play with this later.
Dad, that's the thing I can get behind.
I'm trying to. Make a tool. Like,
Okay, and you can do that later. I need you to have your student companion out so you can be with us for the, when we use the numbers. Okay? Can you get that book out that I had you put away? All right. So, I want you to look at number 3. In number 3, I'm asking you to find CD. So if I'm asking you to find an unknown amount, like we label it with a variable, I'm going to label it X. Okay? Does that look like that picture?
Yeah.
Okay, yeah, it's just turned, right?
Wait.
So, I know, since I have the 2 pieces of our hypotenuse, we know that X is the geometric mean between 5 and 15. So X gets put in our proportion twice, 5 and 15 the others. Now, if you want to draw your similar triangles and set up a proportion that way, you go for it. But the geometric mean is going to happen every time. Sometimes it's just a little faster. Yes?
How do you decide what's A and what's B?
Doesn't matter. Because they're going to get multiplied in our proportion. Yep.
Then it's X squared.
It is. So then we get X squared equals
I just told you.
No, that's what I told you.
75.
Standing this whole.
What?
Wait, so then you do the square root.
Which is why I had you do what we did.
Wait, so X equals
So Hayden said, hey, 75 is 25 times 3. So this is 5 radical 3.
Whoa.
Not that bad, right? Don't you love it when everything comes together?
5 radical 3. X equals 5 radical 3.
All right, now, that is not the only shortcut. Down by example 4, I want you to draw that picture again, just like we did up here. Yeah. I'm just pointing out where I want you to draw it, Aaron Liddy.
Did you see that right triangle? We're gonna draw so many of these triangles.
Huh?
We're gonna draw so many of these triangles.
Yeah. Well, I don't know. Okay. So, another shortcut is if we have the leg of the big right triangle, it is the geometric mean between this piece closest to it and the full hypotenuse. So,
what? Wait, why is the B all the way down instead of just on one part?
because we're working with, like up here, we had the altitude was the geometric mean. Now, if we draw our similar triangles, since we have a piece of the big, we have to have another piece of the big. Okay? No, I'm just like trying to make a point. Okay?
Yeah, no.
But we don't have that on this one.
All right. So, do you see how number 4 is the same picture? It's just kind of rotated. Okay. So let's first focus on JL. So I'm going to call JLX. Can you do that also? Okay. Since x is on the leg of the big triangle, then we know it's the geometric mean between this little piece 4 and what?
All of the
The whole thing, which is what? 24. So we're going to say x is the geometric mean between 4 and 24.
96. Don't worry, guys.
Shh. Just, okay, I love that you want to work ahead, but also, like, wait, okay? That's okay. When we cross multiply, these fellas are saying x squared is 96. Okay. And if x squared is 96 and we take the square root,
Well, I'm going with it.
It's 32 divided.
isn't it 16 times 6?
Yeah.
Do you want to know how I knew that so fast?
Because 32 and then.
Because it was 4 times 24, and 24 is 4 times 6, so I knew that 4 times 4.
Yeah. Okay. You lost me.
Okay.
I'm looking first.
So we have 4. Okay. You all are ridiculous.
I was just all just all
What is it? 4, 6?
You lost me at 4 times 4. That's the first thing she said.
The last thing she said.
Okay, no, she was like, so like 24 is 4 times 4 times 6. And then she like 4 times 4.
All right. Now, what about KL? KL. Let's call KL. Let's call KL Y. Ty, what numbers are important if I'm going to solve for Y?
It's just 424.
I am asking Ty.
Sorry.
And you're wrong. If I'm solving for Y, which numbers are important? I'm asking Ty. Yes. Y is the geometric mean between 20 and 24 because we grab the big side, the little piece, and the big. Yes.
Can't you just solve it backwards with Pythagorean theorem now that you know x and...
You could, if you want to use the Pythagorean theorem with a radical, you go for it. If you know how to do that, you can go for it. Okay? You could also do this. Y squared equals, what's 20? What's 20 times 24?
40.
48.
40. 40.
480.
That's what I was saying.
And that's that's 48 and 10, right?
No, you weren't.
4.8 in 100.
16 times what?
I'll think even better. Later. 30.
16 times 30?
Yeah.
Okay.
Yeah, I trust the calculator.
So 4 square root 30? And 30, there are no perfect squares in 30?
I'm not thinking.
3 and 10. 6 and 5.
Mine was more sharp.
Tired out.
Yours is squared.